All right, good morning all. Hope everyone is doing well. My name is Matt Costner and I am one of the Fortinet SCs in the South Carolina territory. I'm actually located in the Greenville, South Carolina area, Simpsonville to be exact, and I've been with Fortinet for a little over 3 years. So before we get started, I would be remiss if I did not introduce the rest of the Fortinet field and support teams for South Carolina. Depending on your company's line of business, you will align with an account team represented on this slide. As a special thanks to the marketing and channel teams for making this event happen. Some of you may remember that Fortinet sponsored the post-conference festivities at Spare Time last year. Since we were unable to recreate this activity in the current climate, we have another offering that I will announce at the end of the demonstration. Today, I wanted to take some time to talk about a new technology segment that is often overlooked. Security operations is achieved through multiple products working in tandem. Today, we are going to concentrate on just one of those. It's a product that we've coined FortiDeceptor. So first, a little bit of background. According to Poneman's 2019 study, they found the global average total cost of a data breach was $3.92 million. For the US alone, the average total cost of a data breach was $8.2 million. This is a huge impact to any organization of any size. To dig deeper on the contributing factors to a breach, we learned from Verizon's 2019 data breach report that of all breaches that organizations faced, 2/3 can be attributed to organized crime that are motivated financially in launching attacks against organizations, while the remaining 1/3 are from the organization's sysadmin or end user community. These are the often overlooked insider threats. And what continues to be a trend is that it only takes minutes for an initial compromise of an asset and subsequent exfiltration of data once the breach is successful. And 56% of organizations took months to discover the breach, and then additional time was needed to take appropriate remediation steps. So why is it a challenge for organizations to discover these threats earlier? Due to the continued shortage of InfoSec talent, overburdened staff can't effectively respond to thousands of alerts received per day, which is paralyzing the response to actual threats. Way too much noise is happening inside of the SOC. And the management of 30+ different security products or solutions in a security architecture that may not naturally share threat intelligence creates an obstacle to a timely overall response strategy to a breach. Fortinet addresses these challenges by offering security solutions for endpoints, access points, network elements, the data center, applications, and the cloud. These components are designed to work together as a cohesive security fabric that can be integrated, analyzed, and managed to provide end-to-end protection for your network. We're going to focus on security operations solutions. The Fortinet security operations solutions deliver advanced threat intelligence and technologies to prevent, detect, and respond to traditional and advanced threats. They also aid with compliance and can help raise overall security awareness. Most security operations are tasked with 4 general goals: prevent cyber attacks, detect advanced threats, respond to incidents, and demonstrate compliance. With the tools listed, we can increase security by keeping pace with the evolving threat landscape, consolidate the tools necessary to minimize missed events, and enrich our threat intelligence with AI-driven threat feeds of malicious files, IP addresses, and more. Fortinet's FortiDeceptor technology provides best-in-class defense and protection with security tripwires, which trigger automated responses against malware and unauthorized users looking to access and exploit networked resources. Prevention and detection are not the only components to having good security posture. Responding and containing an incident is still a top priority for CISOs in 2020. However, response time is detecting breaches is still taking companies around 200 days. Using the security fabric, security operations can gain the ability to respond to incidents across Fortinet and non-Fortinet components with automated actions through flexible workflows and event triggers, and all through a single pane of glass management console. To break down how security solutions deal with threats, it is common to find there is a set of products or solutions that deal with insider threats and another for external threats. It would be optimal if there was a solution that could protect against both external and internal threats at the same time. FortiDeceptor combines the notion of a honeypot with threat analytics and threat mitigation into one. Specifically, FortiDeceptor creates decoys to lure attackers and inspects their behavior to generate accurate threat intelligence and to block both external and internal attacks. Fortinet is the first major security vendor to offer deception technology, and the offering is available as an appliance as well as a virtual form factor. Furthermore, FortiDeceptor is integrated with the FortiGate firewall as part of the automated threat response process and with FortiSIEM and FortiAnalyzer for broader visibility. Normally, the first endpoint an attacker compromises is only used to gain access to the organization's network. Once compromised and controlled, the attacker uses this host to explore the network, find their next target, and move from host to host as they search for the data and assets that they are after for their attack campaigns. As part of this lateral movement, FortiDeceptor redirects attacks to decoy and real devices equipped with lures that appear indistinguishable from real IT and OT assets. These decoys are highly interactive. This allows organizations to detect they have been compromised before the attacker has a chance to achieve their goal. One key advantage of FortiDeceptor is that it allows organizations to centrally manage and automate the deployment of pre-built or custom decoy VMs and lures, which results in a rapid deployment, usually within a single day. To eliminate the initial compromise and breach dwell time, and also the challenge with too many alerts that create noise, FortiDeceptor acts as an early warning system that exposes an attacker's malicious intent that translates to immediate alerts sent to the security teams or SIEM for review and validation. FortiDeceptor applies analytics to a consolidated set of security events, then correlates and attributes them to the threat actor along with a timeline of activities, which helps bring to the surface the larger threat campaign in a single pane of glass. To help the lean InfoSec team scale and create a seamless consolidated threat response, FortiDeceptor allows security analysts to manually investigate and apply manual remediation or automatically block these attacks based on severity before actual damage occurs via an integration with the FortiGate firewall. To provide further contextual intelligence for the attacker's activity, FortiDeceptor uses an anti-reconnaissance and an anti-exploit service that comprise of 3 detection engines that are powered by FortiGuard labs. The AI-enabled anti-malware service, the AI-enabled web filtering service, and lastly, IPS detection. These services allow the detection of malware, malicious URLs, exploits, and network-based attacks observed within the decoys. It allows the security team to drill down to a threat campaign, correlate its activities, and accelerate analysis of the threat. Integration with the FortiGate devices allows for an automated mitigation of that threat. FortiDeceptor is very flexible, allowing organizations to deploy the solution either as an appliance or a virtual form factor on-premise. All the while, the network of decoys can cover the entire organization from branch locations to the campus, data center, public cloud, and even the operational technology networks. The deception VMs offered today simulate Windows, Linux, industrial control systems, and other SCADA devices. So in summary, organizations have to deal with breaches that can originate either from external or internal threats. FortiDeceptor helps with this redirecting these attacks and by analyzing the attacker's behavior, which provides SOC teams actionable intelligence to respond to these threats. Through the security fabric, security teams can share intelligence with a SIEM for broader visibility, and inline security controls can block both external and internal actors automatically before any damage is done. FortiDeceptor is a holistic solution covering the entire organization for both IT and OT segments. All right, so from here, I want to run a couple scenarios in a lab environment and kind of show you how the product works. So let me share my screen here. So hopefully everyone can see my screen. So let me kind of set the stage. We're going to go through both kind of playing the offense and the defense in this scenario. The scenario is that we have already compromised a machine inside of a company's DMZ. We've done some research as well. We know this company uses the syntax of first initial, last name for usernames. So we're going to use that to our advantage. And we're going to run through kind of an escalation of, or a stair step of attacks on a box that's going to be our pivot point inside of the DMZ. But first, I want to jump into the FortiDeceptor console and kind of show you how easy it is to deploy some of these decoy VMs into the network. And we'll start here with the dashboard, which I call kind of your 30,000 foot view. From here, you can actually see all the different events and incidents that are we actually were able to detect. So all of your events are going to be in the inner circle, and then all the incidents that comprise of all the events will be on the outer circle. And you can see the different severity levels here: critical, medium, low, and high. Then we want to look at the different lures or applications or services that are actually deployed as part of these decoy VMs out in the environment. So you see some ones that you're actually probably familiar with: SMB, RDP, SSH, and then some stuff that's actually associated with OT networks. So BACnet and Modbus. So if you're not as familiar with OT, you may not be as familiar with those protocols. We get some good information here, and these are actually configurable widgets, so we can change the timeline associated with a lot of these. I think we have 3 options here: 24 hours, 7 days, and 4 weeks. So we keep the analytics for a good period of time. We're also handing this off to a SIEM or FortiAnalyzer as well for long-term storage. But you can see I've got a lot, and I actually have to preface this. Actually, before I put this up for the B-Sides demo, I actually opened up a couple boxes to the outside to generate some traffic. So there was a Windows box that had RDP enabled. There was a Ubuntu box that had SSH enabled, and then they're all going to be using simple username password combinations. So that's why you're seeing all of this information here. So these are the incidents in the last 7 days. And of course, here are the events that actually make up those incidents. A lot from China, right? Kind of surprised so much from France, but you can actually look at it on a geographical map here. So we've got China having 918 incidents, Russia in the 5,000, and surprisingly, for some reason, I don't know why this surprises me, but France is actually the leader here with over 20,000 incidents. The good guys in Canada don't seem to be wanting to attack me for some reason. Distribution of services, like I said before, RDP, SSH, we can do TCP listeners on specific ports, and I'll get into that a little bit later. And then just your overall incidence over time. Again, we can change the time value for this. So let's look and see what actually goes into building out this deception network. So here are the options we have from an OS standpoint. So we can actually pull a FortiGate firewall image down, and that's the only one I haven't pulled down here. And then beside this, you can see which lures are associated with which images. So the FortiGate would be associated with a VPN connection. We would set it out on the edge. We would put a simple username and password on it, and hoping someone could actually compromise the box and then start to pivot. And that's pretty much the case for all of these. We want them to compromise the box. We want to see what they're doing, what the next steps are, what tools they're trying to download, so we can prepare to how to mitigate that threat. So we got some SCADA devices here, and this SCADA device is actually an Ubuntu box that actually has some code on it that simulates a SCADA or an ICS device. And again, we can see the lures that are available for this box as well. And then we've got an Ubuntu Linux box and a couple flavors of Windows 7 and Windows 10. SSH for Ubuntu, RDP for remote management access for these Windows boxes, and SMB and Samba, as well as any TCP listeners that you wanted to set. So once we download these images, you can see these are initialized and this one's still outstanding, but once we have these downloaded, all we have to do is build out a deployment network. Typically, port number 1 is going to be reserved for management, so it's going to be on the safe side of the network or the trusted side, usually in a network management VLAN. Any other port can be used for deploying of decoys into the environment. So from here, I've actually just created 2 networks, 2 different DMZs, and then I can deploy the decoys out. This is a VM that I'm running right here for FortiDeceptor. I could pull a trunk into VMware and actually set up auto VLAN detection or manually set VLAN IDs. These IP addresses are mainly going to be used for proxy purposes into the VMs, and I'll show you that shortly. But that's pretty much, once you download the image files, you set up the networks, and the last step is just to deploy the actual decoy VMs. So I've got a template here. I'll jump into that. I'm going to name it test just to be simple. But you can see the services that are enabled here. RDP, I can set my username and password. If I wanted an SMB share, same thing. And then I can give it a creative, enticing name like banking or private, something like that. And then a TCP listener, I've got it set up as port 80, but I see a lot of times this comes in handy to where if you had a custom application, well, not really custom application, but an application that you were hosting internally that maybe had an odd port number that you wanted to advertise and see if someone could pick it up as that service and start sending exploits towards that, this is where that TCP listener would be handy here. So once we do this, we just click next, and this is where you actually add that interface from the deployment network step earlier right into here. So I'm going to select port 2. I can select DHCP, so I'm just going to grab a regular DHCP address from your DHCP server. I can set it statically if you want to, no big deal there, and then that's it. You just click deploy. Once you click deploy, all of your decoys will show up here. You can see I've got a couple of Ubuntu boxes out, a couple Windows 7. I got a SCADA device sitting out there. And then it's just typical controls. If I wanted to see how this box is configured, I can click on it and see exactly what's configured, usernames, password, that kind of stuff, right? And if I wanted to jump into a box, I can easily just VNC directly into it here. We're using that proxy IP that we set up earlier in order to do this, so we're still on the safe side of the network. And the same thing for the Windows side. I can open up an RDP session directly from here. So we have access to the VMs via proxy, so everything's safe. And you can see the services that I've got listed here. So SMB Samba, SMB here for Windows, a TCP listener here on port 80. So we're going to actually hit these boxes as part of this demonstration. The decoy map is going to be more of what's out there, what do we have running. Same thing, here's our decoys. Anything that's red is critical. We can click on any of this stuff, view incidents. It's not typically what I use. I usually just go to the analysis engine here inside of FortiDeceptor, but we'll get to that here in just a moment. So let's go ahead and jump over to our Kali Linux box. So this is going to be the box that I stated that we compromised. I know we're not going to compromise a Kali Linux box in real life. We're just going to have to make believe here just a little bit. So I'm going to go ahead and start off with just running a simple nmap scan against one of these decoy VMs. And then we're going to look and see, we'll flip back and forth. We'll go offensive, then we'll flip over to FortiDeceptor, see what we can see from a defensive standpoint, and see if the analytics make sense. So I'm going to go ahead and pull up a couple of command line scripts that I've got here, and we're just going to quickly run them. So .48, that's the Ubuntu box, that decoy that we looked at earlier. So we'll let this run just a minute and we'll see what we get back. All right, so we got a response after a little while. So we can see the ports that are actually open on this decoy box. Of course, we don't know it's a decoy. We're inside of a customer's, or not customer, company's network, and we're trying to pivot at this point. So we see SSH, 80's listening, we got NetBIOS, we've got SMB running. So let's go back to the defensive side and let's see if we can see any of this stuff. So we're gonna go to analysis. And we're going to see on this side, there's actually a couple of events that happened, right? Because we're scanning multiple ports. So port 22, 139, 443. So these are lining up with exactly what the results that we got from the nmap scan. And we can see all the source ports that we used in order to do this. We actually can pull down the PCAP for this transaction if you wanted to. So we were able to capture that nmap scan. Still not as concerning, right? You know, nmap's concerning, scans are concerning, inside your network more so, right? But not as big of a deal. It's not going to create a campaign out of it yet. So let's go back and let's dig a little bit deeper. So the next thing I want to do is, I told you before that I've done my research. I know that the syntax for username and passwords inside of this company is first initial, last name. I know there's a John Smith. So we're going to go after John Smith, and we're going to use Hydra and do a brute force password attack using a word list from Metasploit. So let's go ahead and copy and paste that in right quick. So the attack has started. I apologize. I quarantined myself. This is something I was going to show you earlier. I thought I'd turn this off, but I did quarantine myself. So we'll go ahead and talk about that while I've got it. So we do have the integration with the FortiGate firewall, where I can actually hit the API on an upstream FortiGate firewall and quarantine devices. So what that means is we're going to show up in quarantine here, which you can see we got 2 minutes left before this guy has fallen off of the quarantine band. I've got it set for 5 minutes. You can set it upwards to, I think, multiple days to quarantine this. So once you're quarantined, we can actually go upstream to the FortiGate firewall and we can actually monitor that as well. So we go into quarantine monitor here, we can actually see that the timers are going to be the same from the API call. We can see the device that's actually the threat. From here, we can actually do some things as far as create address objects out of it. So we can put it on a bad list. We can quarantine it all together. So there's two different types of quarantine. One's a band quarantine, which is going to be temporary and more NAC based. And then we can actually quarantine the host all together to where it can't pass traffic. We do have some integrations if you used our secure access switching and wireless to where we can actually do this before it actually gets into the fabric altogether. And then we can actually build out some automation as well, which is kind of cool. So once I built out an automation step for this, and I'm not really doing anything but sending an email, but we can run CLI scripts and we can actually do things to this endpoint in addition to banning the IP address on the FortiGate firewall. Maybe we want to set off a script for something that we can do from a security operations standpoint in the SOC. But it depends on the event that you choose. And again, all I've done is looking at event, NAC quarantine. I'm going to send an email, and then here's the email address I'm going to send it to. And it'll just show up in your inbox. So that was something I was going to cover a little bit later, but since I blocked myself, then I figured it might as well use the time wisely here. So let's give it another 20 seconds, and we'll run that again. But as you can see, that quarantine does work. We weren't able to run the brute force attack from there. So refresh here. Looks like we're good. Let's go back to FortiDeceptor. We'll refresh here. Looks like we're good. Let's go ahead and run that attack again. All right, so this time it worked. We didn't quarantine ourselves. And you can see it took 3 tries in order to guess the password of password. Yes, we made this really, really simple. We want these decoys to be compromised. We want to see where they're pivoting, what tools they're using next. So let's go back to FortiDeceptor and let's take a look at the analysis. And we should see something new, and we do. We actually see, you see, I did some testing earlier, but you actually see there was no username before we actually did the brute force attack. So now we actually know the username used in this transaction, and we can actually go through showing that an SSH session was established, 2 wrong passwords were guessed, and then we actually were able to guess the password on the 3rd attempt. So we see all of that activity, so we're good so far. So let's go a little bit deeper. Let's run some commands. Right, so we've got interactive access, or we are going to have interactive access to the console. Let's go ahead and log into this box since we know the username and password now. Password is password. So now we're on that box, that decoy, although we don't know it's a decoy. I'm going to just run some commands and see what we got. We got a loopback address, the interface that I came in on. It looks like we have another interface, so this box is multi-homed. That could be interesting for pivoting out. Let's see if we can see any files, hidden files. Yep, we got some files here in the home directory that that we just done a list on. I want to look at that history file there. See, yep. So you could pick up some interesting things there depending on who was in here before. So let's do something else. Let's actually let's do something a threat actor would actually do. So let's go and grab some tool sets. And this is not malicious tool sets, right? This is just going to emulate that. But this is what they would do. They would go out, grab a tool from a website, and be able to pull the tool down and use it to pivot or move laterally inside the network. So we're going to use this site, and this is just a simple HTML file. So we downloaded that. There's the file. So let's go back to FortiDeceptor and see what we can see again from the analysis tab. So we've got an interaction here. Again, we got the attack user, source port. We started the session again. We're coming in here, and here we go. Here are all the commands that the threat actor actually ran during his session. The other thing is, let's look at the web filtering events, and we can actually drill down to this and see that there was a, well, here we go. There was a malicious website hit. So the threat actor actually hit this website. If we wanted to go even further, I can pull this PCAP and I can look at the URI that was actually used. What package, what tool set did they pull down? Gives you more visibility into knowing what you're up against when someone's actually inside your network already. So I got one more step, or one more attack that I want to place forward on this machine. And it's going to be an exploit attack. And actually, I'm changing machines now, but it's going to show you the same thing. So I'm going to do a Windows attack on a Windows machine. This is an old DCOM attack. I got to update my sources, but let me go ahead and just run this attack on this machine. And the attack is actually going to fail. This is an updated version. Actually, this is Windows 7. This exploit was originally built for Windows 2003 server. So this is going to fail, but we want to look at what we're seeing in FortiDeceptor from an analytics standpoint. That's the most important thing. So we're going to go and look at IPS events. And then we can actually look at the victim port. It's 135. And we can actually see the IPS attack that actually happened. We can pull again the PCAP associated with this, and we can actually see the attack or remote activation request here. So a lot of good information. So we've covered pretty much scanning. We've covered any kind of remote tool sets that are needed to be downloaded, any malicious code that's downloaded. We've covered any kind of exploits or network-based attacks. We've been able to see all of that so far. So from the offensive side, we're done. We're going to go in here and talk about a couple more things. One we've already talked about was the integration with the FortiGate, because I accidentally quarantined myself in advance. But this time I want to look at the actual lures that you can put on legitimate machines. So the machines may be inside your network. Maybe you've got a finance VLAN, maybe in the DMZ. We can actually pull tokens from these decoys. And what that means is I can pull a token package and install them on legitimate machines. And maybe these tokens will lead the threat actor to the decoys by hiding cache credentials on those machines for RDP or SSH. Maybe there's a symbolic link pointing to a share, again, called banking or private, that would entice a threat actor that's already compromised a legitimate machine to start showing themselves by attacking a decoy elsewhere in the network. So there's some cool things that we can actually deploy to legitimate machines to push them over to attack one of the decoys that you've got sitting out there in the network. I think that is about it, since we've already covered the FortiGate piece.